welcome friends. Welcome to DLTGH. Today we are going to read that lesson, Chemically Reactions and Equations, Chapter 1 of Science. Consider the following of daily life and think what happens when milk is left at room temperature during summers, an iron tawa or pan or nail is left exposed to humid atmosphere, grapes are get fermented, food is cooked, food get digested in our body, we respire. In all above situations, the nature of and the identity of initial substance have somewhat changed. We have already learned about physical and chemical changes of what in our previous classes. Whenever a chemical changes occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what is actually meant by a chemical reaction. How do we come to know that a chemical reaction has taken place? Let us perform some activities to find the answer to these questions. Activity 1.1 Caution. This activity needs the teacher's assistance. It would be better if students wear eye protection. Step 1 Clean a magnesium ribbon about 2 cm long by rubbing it with sandpaper. Step 2 Hold it with a pair of tongs, burn it using a spirit lamp or burner and collect the ash so formed in a watch glass as shown in figure 1.1. Burn the magnesium ribbon, keeping it as far as possible from your eyes. What do you observe? You must have observed that magnesium ribbon burns with a dazzling white flame and changes into white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in air. Activity 1.2 Take a lead nitrate solution in test tube. Step 2 Add potassium iodide to solution. Step 3 What do you observe? Activity 1.3 Take a few zinc granules in a conical flask or a test tube. Step 2 Add dilute hydrochloric acid or sulfuric acid to this. Caution. Handle the acid with care. Step 4. Do you observe anything happening around the sin granules? Step 5. Touch the conical flask or test tube. Is there any change in its temperature? From the above three activities, we can say that any of the following observations help us to determine whether a chemical reaction has taken place. Number one, change in state. Number two, change in color. Number three, evolution of gas. And number four, change in temperature. As we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical reactions and symbolic representation in this chapter. Chemical equations. Activity 1.1 can be described as when magnesium ribbon is burned in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write it in the form of a word equation. The word equation for the above reaction would be magnesium plus oxygen gives magnesium oxide. In this, magnesium and oxygen is the reactants and magnesium oxide is the product. The substance that undergo chemical change in reaction shown in 1.1, magnesium and oxygen are reactants. The new substance magnesium oxide formed during the reaction is the product. A word equation shows the change of reactants to product through an arrow placed between them. The reactants are written on the left side LHS with a plus sign between them. Similarly, products are written on the right hand side RHS and with a plus sign between them. The arrowhead points towards the products and shows the direction of the reaction. Writing a chemical equation. Is there any other shorter way for representing a chemical equation? Chemical equations can be made more concise and useful if we use chemical formula instead of words. A chemical equation represents a chemical reaction. If you recall formula of magnesium oxygen and magnesium oxide, the above word equation can be written as Mg plus O2 gives MgO. Count and compare the number of atoms of each element and on the LHS and RHS of the arrow. Is the number of atoms of each element the same on the both sides? If not, then the equation is unbalanced because the mass is not the same on the both sides of the equation. Such a chemical equation is skeletal chemical equation for a reaction. Equation 1.2 is a skeletal chemical equation for the burning of magnesium in air. Balanced chemical equations. Recall the law of conservation of mass that you studied in class 9. Mass can be neither be created nor be destroyed in a chemical reaction. That is, the total mass of the elements present in the product of the chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Is the chemical equation 1.2 balanced? Let us learn about balancing a chemical equation step by step. The word equation of activity 1.3 may be represented as zinc plus sulfuric acid gives zinc sulfate plus hydrogen. The above word equation may be represented by following chemical equation. Iron plus H2SO4 gives SO4 plus H2. Let us examine the number of atoms of different elements on both sides of the arrow. Iron, that means zinc, is 1 and 1 on the right are RHS and LHS2. Hydrogen is 2 on the LHS and 2 on the RHS. Sulfur on 1 on the LHS and 1 on the RHS. And oxygen 4 on the LHS and 4 on the RHS. As the number of atoms of each element is same on both sides of the arrow, equation 1.3 is balanced chemical equation. Let us try to balance the following chemical equation. Fe plus H2O gives Fe3O4 plus H2. Step 1. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the box while balancing the equation. Step 2. List the number of atoms of different elements present in unbalanced equation 1.5. In this, iron in LHS is 1 and RHS is 3. Hydrogen in LHS is 2 and RHS is 2. Oxygen in LHS is 1 and RHS is 4. Step 3. It is often convenient to start balancing with the compound that contains a maximum number of atoms. It may be a reactant or a product. In that compound, select this element which has a maximum number of atoms. Using these criteria, we select Fe3O4 as and the element oxygen in it. There are 4 oxygen atoms on the RHS and only 1 on the LHS. To balance the oxygen atoms of oxygen, initial 1 in H2O, in product 4 in Fe3O4. To balance in reactants 1 into 4 and in product it will be remain the 4. To equalize the number of atoms, it must be remembered that we cannot alter the formula of compounds or elements involved in the reactions. For example, to balance oxygen atoms, we can put coefficient 4 as 4H2O and not H2O4 or H2O bracket close 4. Now, the partly balanced equation becomes Fe plus 4H2O gives Fe3O4 plus S2. Step 4. Iron and hydrogen are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 on the RHS. Initial reactant 8 in 4H2O in product 2 in H2. To balance, reactant will be remain same and product will be multiplied by 4. The equation would be Fe plus 4H2 gives FeO4 plus 4H2. Step 5. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. Initial in reactants 1 and product 3 in Fe3O4. To balance reactant into 3, that gives 3, in product it will remain 3. To equalize iron, we take 3 atoms of iron on LHS. 3Fe plus 4H2O gives FeO4 plus 4H2. That is 1.8 equation. Step 6. Finally, to check the correctness of the balance equation, we count atoms of each element on both sides of the equation. 3Fe plus 4H2O gives Fe3O4 plus 4H2. This is 1.9 and it's a balance equation. The number of atoms of elements on both sides of equation 1.9 are equal. This equation is now balanced. This method of balancing chemical equation is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Step 7. Writing symbols of physical states. Carefully examine the above equation 1.9. Does this equation tell us anything about the physical state of the each reactant and product? No information has been given in this equation about their physical states. To make a chemical equation more informative, the physical states of reactants and products are mentioned along with the chemical formula. The gaseous, liquid, and aqueous are solid states of reactants and products are represented by the notations G, L, AQ, and S, respectively. The word aqueous AQ is written if the reactant or product is presented as solution in water. The balance equation 1.9 becomes 3Fe, that's solid, plus 4H2O it gives Fe3O4S plus 4H2G. This is equation 1.10. Note that the symbol G is used with H2O to indicate that in this reaction water is presented in the form of steam. Usually physical states are not included in chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and or below the arrow in the equation. For example, COG plus 2H2G of 340 atom gives CH3OHL. This equation 1.11. 6CO2 AQ plus 12H2OL using sunlight and chlorophyll gives C6H12O6 aqueous plus 6O2 aqueous plus 6H2O liquid. This is equation 1.12. Using these steps, can you balance equation 1.2 given the text earlier? Types of chemical reactions. We have learned in class 9 that during a chemical reaction, atoms of one element do not change into those of another element. Nor do atoms disappear from the mixture of appear from elsewhere. Actually, a chemical reaction involves the breaking and making of bonds between atoms to produce new substances. You will study about types of bonds formed between atoms in chapter 3 and 4. 1.2.1 Combination reaction. Activity 1.4. Take a small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Touch the beaker as shown in figure 1.3. Do you feel any change in temperature? Calcium oxide reacts vigorously with water to produce slaked lime. Calcium hydroxide released a larger amount of heat. CaO is quicklime plus H2OL gives CaOH2 aqueous, that is slaked lime. This is equation 1.13. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as combination reaction. Let us discuss some more example of combination reactions. Burning of coal. Cs plus O2G gives CO2G, that is equation 1.15. Formation of water from H2G and O2G. 2H2G plus O2 gives 2H2L. That is equation 1.16. In simple language, we can say that when two or more substance elements or compounds combine to form a single product, the reactions are called combination reactions. In activity 1.4, we also observe that a large amount of heat is evolved. This makes the reaction mixture warm. Reaction in which heat is released along with the formation of product are called exothermic chemical reactions. Other examples of exothermic reactions are burning of natural gas. CH4G plus 2O2G gives CO2G plus 2H2OG. This is equation 1.17. Do you know that respiration is an exothermic process? We all know that we need energy to stay alive. We get this energy from food we eat. During digestion, food is broken down into simpler substances. For example, rice, potatoes, and bread contain carbohydrates. These carbohydrates are broken to form glucose. This glucose combines with oxygen in the cells of our body and provide energy. The special name of this reaction is respiration, the process of which you will study in chapter 6. C6H12O6 aqueous plus 6O2 aqueous gives 6CO2 aqueous plus 6H2OL plus energy. This is equation 1.18. Third, the decomposition of vegetable matter in compost is also an example of an exothermic reaction. Identify the type of reaction taking place in activity 1.1, where heat is given out along with the formation of a single product. 1.2.2 Decomposition reaction. Activity 1.5. Take about 2 gram ferrous sulfate crystal in dry boiling tube. Note the color of the ferrous sulfate crystals. Heat the boiling tube or the flame of a burner or spirit lamp as shown in figure 1.4. Observe the color of the crystals above heating. Have you noticed that the green color of the ferrous sulfate crystals has changed? You can also smell the characteristic odor of burning sulfur. 2FeSO4 solid with the presence of heat gives Fe2O3S plus SO2G plus SO3G. This is equation 1.18, where it gives ferrous sulfate to ferric oxide. In this reaction, you can observe that a single reactant breaks down to give a simple products. This is a decomposition reaction. Ferrous sulfate crystal FeSO4 and 7H2O lose water when heated and the color of crystals changes. It then decomposes to ferric oxide Fe2O3 and sulfur dioxide SO2 and sulfur trioxide SO3. Ferric oxide is a solid while SO2 and SO3 are gases. Decomposition of calcium carbonate to calcium oxide and calcium dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called the lime or quicklime. It has many uses. One is in the manufacture of cement. When a decomposition reaction is carried out by heating, it is called thermal decomposition. CaCO3 is limestone in the presence of heat may convert to CaOS quicklime plus CO2G. This is equation 1.20. Another example of thermal decomposition reaction is given in activity 1.6. Take about 2 gram lead nitrate powder in a boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame, as shown in figure 1.5. What do you observe? Note down the change if any. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide, NO2. The reaction that takes place is 2PbNO3 2S lead nitrate in the presence of heat gives 2PbOS lead oxide plus 4NO2G nitrogen dioxide plus O2G oxygen. This is 1.21 equation. Let us perform some more decomposition reaction as given in activities 1.7 and 1.8. Take a plastic mug, drill, drill two holes at its base and fill rubber stoppers in these holes. Insert carbon electrodes in these rubber stoppers as shown in figure 1.6. Connect these electrodes to a 6-volt battery. Fill the mug with water such that the electrodes are immersed. Add a few drops of dilute sulfuric acid to the water. Take two test tubes filled with water and invert them over the two carbon electrodes. Switch on the current and leave the apparatus undisturbed for some times. You'll observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tubes. Is the volume of gas collected the same on the both of the test tubes? Once the test tubes are filled with its respective gases, remove them carefully. Test these one by one by bringing a burning candle close to the mouth of the test tubes. Caution: this step must be performed carefully by the teacher. What happens in this case? Which gas is present in each test tube? Activity 1.8. Take about 2 grams silver chloride in a china dish. What is its color? Place this china dish in sunlight for some time. Observe the color of silver chloride after some time. You will see that the white silver chloride turns gray in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. 2 AgCls in the presence of sunlight gives 2 Ags plus Cl2G. Silver bromide also behaves in the same way. 2 AgBrs in the presence of sunlight gives 2 Ags plus Brg. The above reactions are used in black and white photography. What form of energy is causing these decomposition reactions? We have seen that the decomposition reactions require energy either in the form of heat, light, or electricity for breaking down of reactants. Reactions in which energy is absorbed are known as endothermic reactions. Displacement reaction. Activity 1.9. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 milliliter copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in copper sulfate solution in test tube B for 20 minutes. Keep 1 iron nail aside from for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of blue color of copper sulfate solution in test tubes A and B. Also compare the color of iron nails dipped in the copper sulfate solution with one kept aside. Why does the iron nail became brownish in color and the blue color of copper sulfate solution fade? The following chemical reaction take place in this activity. FeS plus CuSO4 aqueous gives FeSO4 aqueous plus Cu. In this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. Other examples of displacement reactions are ZnS plus CuSO4 aqueous copper sulfate gives ZnSO4 aqueous zinc sulfate plus Cus. PbS plus CuCl2 aqueous copper chloride gives PbCl2 aqueous lead chloride plus Cus. Zinc and lead are more reactive elements than copper. They displace copper from its compounds. Double displacement reactions. Activity 1.10. Take about 3 milliliter of sodium sulfate solution in a test tube. In another test tube, take 3 milliliter of barium chloride solution. Mix the two solution. What do you observe? You will observe that a white substance which is insoluble in water is formed. This insoluble substance formed is known as a precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. NaSO4 aqueous sodium sulfate plus BaCl aqueous barium chloride gives BaSO4S barium sulfate plus 2NaCl aqueous sodium chloride. What causes this? The white precipitate of BaSO4 is formed by the reaction of SO4 2 minus and Ba2 minus 2 plus. The other product formed is sodium chloride, which remains in the solution. Such reactions in which there is a exchange of ions between the reactants are called double displacement reactions. Recall activity 1.2, where you have mixed the solutions of lead 2 nitrate and potassium iodide. What was the color of the precipitate formed? Can you name the compound precipitated? Write the valence equation for this reaction. Is this also a double displacement reaction? 1.2.5 Oxidation and reduction. Activity 1.11. Heat a china dish containing about 1 gram copper powder. What do you observe? The surface of copper powder becomes coated with black copper 2 oxide. Why has this black substance formed? This is because oxygen is added to copper and copper oxide is formed. 2CO plus O2 in the presence of heat gives 2CO, CuO. If hydrogen gas is passed over this heated material CuO, the black coating on the surface turns brown as the reverse reaction takes place and copper is obtained. CuO plus H2 in the presence of heat gives Cu plus H2O. If a substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. During this reaction 1.29, the copper 2 oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. In other words, reactant gets oxidized while the other gets reduced during a reaction. Such reactions are called oxidation reduction reactions or redox reactions. CuO2 reduced to Cu and H2 oxidized to H2O. Since other examples of redox reactions are ZnO plus C gives ZnCO. MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. In reaction 1.31, carbon is oxidized to CO and ZnO is reduced to Zn. In reaction 1.32, HCl is oxidized to Cl2 whereas MnO3 is reduced to MnCl2. From the above examples, we can say that if a substance gains oxygen or loses hydrogen during a reaction, it is oxidized. If a substance loses oxygen or gains hydrogen during a reaction, it is reduced. Recall activity 1.1, where a magnesium ribbon burns with a dazzling flame in air, oxygen, and changes into white substance, magnesium oxide. Is magnesium being oxidized or reduced in this reaction? Have you observed the effect of oxidation reactions in everyday life? 1.3.1 Corrosion. You must have observed that iron particles are shiny when new, but when coated with reddish brown powder when left for some time. This process is commonly known as rusting of iron. Some other metals also get tarnished in this manner. Have you noticed the color of coating formed of copper and silver? When a metal is attacked by substance around it, such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. The black coating on silver and green coating on copper are other examples of corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, and to all objects made of metals, especially those of iron. Corrosion of iron is a serious problem. Every year, an enormous amount of money is spent to replace damaged iron. You will learn more about corrosion in Chapter 3. Rancidity. Have you ever tasted or smelled the fat or oil containing food materials left for a long time? When fats and oils are oxidized, they become rancid and their smell and taste change. Usually, substances which prevent oxidation, antioxidants, are called to foods containing fats and oils. Keeping good food in airtight containers help to slow down oxidation. Do you know that chips manufacturers usually flush bags of chips with gas such as nitrogen to prevent the chip from get oxidizes? What you have learned? A complete chemical equation represents the reactants, products, and their physical states symbolically. A chemical equation is balanced so that the number of atoms of each type involved in a chemical reaction are the same on the reactant and product sides of the equation. Equation must always be balanced. In a combination reaction, two or more substances combine to form a single new substance. Decomposition reaction are opposed to combination reactions. In a decomposition reaction, a single substance decomposes to give two or more substances. Reactions in which heat is given out along with the product are called exothermic reactions. Reactions in which energy is absorbed are known as endothermic reactions. When an element displaces another element from its compound, a displacement reaction occurs. Two different atoms or groups of atoms, ions, are exchanged in double displacement reactions. Precipitation reactions produce insoluble salts. Reactions also involve the gain of loss of oxygen or hydrogen by substances. Oxidation is gain of oxygen or loss of hydrogen. Reduction is a loss of oxygen or the gain of oxygen, hydrogen. Thank you for watching the video. If you like the video, please subscribe and like the video. If you want to share it to your friends, please share it to your friends. Thank you for watching the video. Till the other video, let's bye bye.